So in this video we're going to look at the compound angle formula. We're going to find values for sine A plus B using the compound angle formula of sine A cos B plus cos A times sine B. We're going to apply it to a phase shifted sine wave where B is the phase shift. So we're going to use the compound angle formula to find out of the sine of 15 degrees plus 15 degrees. But we know what the answer is because the sine of 30 degrees is a half, 0.5. So we'll do it with the compound angle formula. So we're going to let angle A be 15, and in this case angle B is 15 too. So the compound angle formula says sine A times the cos of B plus the cos of A times the sine of B is the same as the way we had it to start with, sine of A plus B. And we're expecting it to equal a half because the sine of a 30 is a half. So in this case A is 15 and B is 15. So we have the sine of 15 degrees times the cosine of the other 15 degrees added to the cosine of A times the sine of B. And on the calculator we can do it in one step if we want to. So this will show you what I'm writing. So we do, if you notice my calculator's in radians mode, so I need to change it to degrees mode, otherwise I won't get the right answer. So now I could do sine 15 times, if you put cosine next to the bracket it knows it's multiplication because they're next to each other. So sine of 15 times the cosine of 15 plus the cosine of A times the sine of B, and that should equal a half. And this is what I've written in the calculator. So it certainly works, but in this case the two angles were the same. So it's not very often you'll get that example. So we'll do another one. So if I said A is going to be equal to 30 and B is going to be equal to 60, both in degrees, and sine A plus B is the sine of A, which is the sine of 30, times the cosine of B, which is 60, plus cos A multiplied by sine of B. And we know that the sine of 90, as in the sine of 30 plus 60, sine of 90 is 1. So our answer is going to be 1, but we won't always know that for our questions. So on the calculator, I'll do sine of A times the cosine of B plus the cosine of A times the sine of B, and that should equal 1. And it does. So this is what I've written, and it's certainly correct. It hasn't told me any of the in-between values because I've done it all in one step, but we could have done it in various steps. So we could have said the sine of 30 equals a half. So there I'd have a half times the cosine of 60, which is a half as well, cosine of 30, which is 0.866, the sine of 60, which is also 0.866. So a half times a half added to these two numbers multiplied equals 1. So you can do it in little steps or you can do it in one step. Either way you'll still get the correct answer. So that is using the compound angle formula. So now we're going to apply it to a voltage I've got V2 because that's what we're going to call it later on. So a voltage that we have has an amplitude of 3 volts, and the value at any given time interval t is equal to 3 times the sine of omega t plus a phase shift of 45 degrees. So here we're going to use the compound angle formula. We're going to let A equal omega t and B equal to 45 degrees. You can do them in radians as well, but then your calculator needs to be in radians and the phase shift needs to be in radians too. But because I've got 45 degrees, then I'm going to keep everything in degrees. So using the compound angle formula, the answer to V2 is equal to 3 lots of what's in here, which is sine A cos B plus cos A times sine B. But we said that A is omega t and B is 45. So the answer is going to be 3 lots of sine omega t multiplied by the cosine of 45 degrees plus the cosine of A, which is omega t, times the sine of 45 degrees. So on the calculator, we need to work out what the cosine of 45 degrees is and what the sine of 45 degrees is. So they're worth writing down. It makes it easier later on. So cosine of 45 degrees is equal to 0.707. And the sine of 45 degrees is also worth that. So we can plug the numbers in now. So V2 is 3 lots of sine omega t times the cos of 45, which is 0.707, added to the cosine of omega t times the sine of 45, 0.707. So this 3 is a common factor, so we can multiply the 3 by this 0.707, multiply the 3 by that 0.707 to multiply out the bracket. We're going to multiply that by 3, and that gives us 2.121. I'll just make a note of that. That's 3 lots of 0.707. So V2 is equal to 3 times 0.707 sine omega t, which is 2.121 sine omega t plus 3 lots of that 0.707 cos omega t. So now we've found out what V2 is, expanded out in the sine A plus B compound angle formula form. And the good thing about this is, if we were then to add a normal sine wave to it, we would add the sine component here, and then we'd find out the resultant waveform.